Now let's talk about log likelihood ratio test of nested models. So this title basically tells us what kind of models the log likelihood ratio test can be used for. Uh, it can only be used for nested models, and later on I'm going to explain what is nested models. So unlike the wall test that checks checks into the distance between, let's say, the noun value here, right? Uh, so the noun value is 0, right? And maximum likelihood estimator beta. Okay, so this is a horizontal distance, right? And the wall test checks into this distance, horizontal distance, normalized by the variance of this log likelihood curve. Okay? So unlike the wall test, instead of uh, measure, gauge the horizontal distance between the maximum likelihood estimator and the noun value here, 0, the log likelihood ratio test or LR test uh, computes the vertical distance of the log likelihood of the full model and a model that's compared to. So here we can call it non-model. Okay, so the LR test estimates both models and compares the unconstrained log likelihood to the constrained log likelihood. And later on, we will see that we have to multiply that difference by 2, and that difference turns into a chi-square, chi-statistic, and then we can conduct a chi-square test. Okay, so that's the general idea of LR test or log likelihood ratio test. So here we have two models. One is called the constraint model. Right? Constraint model is the unconstrained model plus the constraints. And the constraint model is said to be nested in the unconstrained model. So the unconstrained model supposedly should have more parameters than the constraint model. And we can look at the following models, right? Model 1, we have this response y equal to 1, the probability, right? And this is a lambda that is the logit link. And 3 parameters, right? Intercept beta 1, beta 2. Then model 2, we have another 3 parameters to be estimated. And model 3, beta 0, beta 1, beta 2, beta 4. And model 4, we have the complete set of parameters, relatively speaking, for the models I just talked about. So when we say nested models, we're talking about, for example, model 1 is nested within, let's say, model 3, right? Because all the parameters combined together is a subset of all the parameters in model 3, right? Beta 0, beta 1, beta 2, plus beta 4, right? How about model 1 and model 2? Well, in this case, they're not nested because in model 1, we have x2 and beta 2, which is not in model 2. And in model 2, we have beta 3 and x3, which is not in model 1. So they're not nested. Okay, now you get a general sense of what is nested model. Basically, the parameters of the model nested within another is a subset of the parameters in the second model, right? So in this case, model 4, model 1, model 2, and model 3 are nested, all nested within model 4. Okay, and so let's look at two models, right? So this model with a subscript of C denotes a constraint model with likelihood of LC, let's say, is nested within MU, that is unconstrained with likelihood of LU. Okay, LU, and the parameter in a constrained model can be created from the unconstrained set of parameters by imposing constraints, simply specifying that some of the parameters in the unconstrained model is equal to 0 or are equal to 0. Okay? So here, the non-hypothesis is that the constraints imposed on some or even all of the parameters in the constraint model are true. Okay? In this case, the likelihood ratio statistic equals, okay, so this is likelihood ratio statistic equals 2 multiplied by the log of the likelihood for the unconstrained model minus 2 multiply the log likelihood for the constrained model. And these statistic under very general conditions, if H known, that is non-hypothesis, is true, then the G here follows a chi-square distribution with degree of freedom equal to the number of constraints. So how many number of constraints you have then? So here we're talking about independent constraints. Then that's degree of freedom for this G square or chi-square, and you can, use a computer software, or you can check into a chi-square table to figure out the probability.